You'll remember on our last set of notes when we talked about the fundamental principle of counting, and we worked some problems, we often had to multiply numbers like 5 times 4 times 3, maybe more like 10 times 9 times 8, but you know what I'm talking about. So those kind of products occur so frequently that they have a special notation, and that's 5 with an exclamation mark after it. And it's read 5 factorial. So the definition for n factorial is n times n minus 1 times n minus 2. So that would translate to, if I have 100 factorial, that's going to be 100 times 99 times 98 times 97, etc. 5 times 4 times 3 times 2 times 1. That's what it means. 0 factorial, notice it doesn't start with 0. It starts instead, it's exactly equal to 1. And the reason that is it works whenever it's substituted that way. All right, so some examples. 4 factorial then would mean 4 times 3 times 2 times 1. So that's 12 times 2 is 24. 6 factorial would be 6 times 5 times 4 times 3 times 2 times 1. So that's what, 30, 120, 360. So that comes out to be 720. Often we'll have some fractions that have factorials in them. And so here, 7 factorial, 7 times 6 times 5 times 4 times 3 times 2 times 1, divided by 6 factorial, 6 times 5 times 4 times 3 times 2 times 1, all multiplications. So notice that all of those cancel, and my answer is just going to be 7. So we do not necessarily have to multiply that all the way out. I could say 7, and when I get to 6 factorial, because I know they're the same products, I can cancel those and get my answer of 7. So we're going to use this on this bigger one here. 101 factorial be 101 times 100 times 99. Oh, and then I notice that it's got a factorial there, so I'm going to stop. I'm going to write the factorial, which means it keeps going. And then down here I have 99 factorial. So those 99 factorials all that cancel out, and I end up with 101 times 100, so 10,100. So now take a minute and try this out in your calculator. That exclamation mark for factorial can be found using the button that's just right of the letter G down on bottom. So give those a try. All right, so now we're going to go to something with the name of permutation. So arrange the letters A, B, and C in as many ways as possible. So notice it says the word arrange. So I want them to be in a special order. So that means that A, B, C is different than A, C, B. So those are different arrangements. Then I might start with a B. So I have B, A, C, and then B, C, A. And then finally I'm going to have C, A, B, and C, B, A. So think about it. Can you arrange them any more ways? I don't think so. And you can see there that we have 1, 2, 3, 4, 5, 6 arrangements. So 6 arrangements of those 3 letters. So often whenever we're counting how many times something occurs, we're called upon to place a group of objects into a certain order. For example, up above, ABC and ACB, BAC are all called different arrangements of the letters A, B, and C. So a permutation permutation is an arrangement of objects in which the order that the objects are placed matters. ABC is different than ACB. So in example 5, how many permutations did we find? Well, we found 6. Use the fundamental counting principle to now calculate the number of possible permutations. So remember when we did the counting principle, we'd think, okay, we have 3 letters, ABC, so 3 letters, and I want to put the first letter down, then I want to put the second letter down, and then I want to put the third one down. So how many choices, if I have the A, B, and C, how many choices do I have to put down to begin with? I have 3. So once I use one of those, then I've got 2 left to put in that second spot. So I used up another one, and now I only have 1. So remember what goes here when we do the fundamental counting principle is the number of choices that I have. So 3 choices times 2 choices times 1 choice. And that ends up with 6 different possible ways of arranging those 3 letters. So 3 times 2 times 1, how can I write this as a factorial? You're absolutely right. That is 3 factorial right there. So in example 5, we found the number of permutations of 3 would be 6. I guess I don't really quite follow what I was writing there, but there you go. For a permutation of n objects taken r at a time, there's actually a formula for it, but you'll see it written this way. Permutation is always going to indicate that we want to have it in a special order. So it needs to be in a special order, so order matters. And you always see that the total number you have to choose from first, that's this first number, and the number of spots that we have to fill second. That's right. So that's going to be, we'll just see how that goes. It's n factorial over n minus r factorial. You do not need to memorize that. We'll be using our calculator to do those things. Okay. All right, so for the next few problems, we're going to calculate the number of possibilities using first the counting principle, and next we're going to use permutation to come up with the answer. So number 6, out of 10 problems, we're going to choose 3 of them, decide which one to put first, second, third. So say I'm making out a test, and I've got this test bank, and I can choose, I want to choose 3 problems. I've got to decide which order I want to put them in. So this order is important, so because I said so, that's what it says, order important. So I have to think that now for what we're going to do later. So fundamental counting principle, I have 3 spots to fill, so there's my 3 spots. For those spots, I have 10 problems to choose between, so I have 10 choices for the first one, 9 choices for the second one, and 8 for the third one. Of course, I'm not going to repeat the same problem over and over again. So 10 times 9 times 8 to get my answer. So 90 times 8 is 720. Then for a permutation, we do a permutation, and we'll do it like we do it on a calculator. It'll be a permutation, and it's going to be 10. So 10, I have 10 choices, and I'm going to choose 3 of them. And because I use the P for permutation, that means that the order is going to be important. So if you put that in your calculator, you should also come up with 720 for my answer. Now, I don't believe we talked about that yet on how to do it on your calculator, unless I skipped it on the last page. To do it on your calculator, you're going to go to your menu. Oh, gosh. All right, I just wanted to double check. You're going to go to your calculator. You're going to go to a calculator page. Then you're going to go to the menu. Then you'll go to number 5, probability. And it'll pull up another menu. And you're going to choose 2, permutation. So you choose a permutation. And when you do that, it will give you a P in a parentheses. And you're going to put a 10, comma 3. All right, so hopefully and pause it and give it a try at doing that. Number 7, out of the senior class of 93 students, select one student to give the commencement speech, one to present the farewell, and one to give the address at the senior dinner. So if they're all equally likely to occur, we don't have any favorites in there, then this is how many choices actually are out there. So we have to give somebody for the commencement speech, then we have somebody to do the farewell, and then somebody to do the address at the senior dinner. So we have 3 places to fill. I have 93 choices. So when I make my first decision, I have 93 people to choose between. So then after that person is chosen, then I'm left with 92 people to choose between, and then 91. So my answer is going to be 93 times 92 times 91, which you can put in your calculator. And if I'm going to do it with a permutation, then I have a permutation. And I use a permutation, again, order's important, of parentheses. I have 93 to choose between, and I'm choosing 3. So 93, and I'm going to choose 3 of them to go in those spots. All right, so we will, again, put these in your calculators to find out what those numbers are and see if they're the same. So we're going to stop these notes right now, and we'll pick up next class and finish the notes and talking about combinations, and we'll contrast them to permutations and talk about the difference when you use a permutation and when you use a combination. So come prepared, knowing what a permutation is. We'll take a quick look at combinations, and then I'll give you an opportunity to make some decisions.